Learning objectives. We will discuss the following topics in this chapter: natural and artificial intelligence, definitions of AI, nature of AI solutions, AI techniques, testing intelligence. 1. Turing test. 2. Chinese room test. Data pyramid. Computer-based information systems in the pyramid. AI applications areas. Mundane tasks, formal tasks, and expert tasks. AI applications areas. Mundane tasks, formal tasks, expert tasks. Mundane tasks. Mundane reasoning means the things which nearly we routinely do to various abilities in order to communicate in the world. This will include perception, vision, speech, natural language, understanding, generation, translation, common sense reasoning, robot control. Formal tasks, games, chess, backgammon, checkers, Go. Mathematics, geometry, logic, integral calculus, providing properties of programs. Expert tasks. Expert reasoning means things in which only some people are good at with their extensive training. It can be especially useful to automate these tasks as there may be a shortage of human experts. Expert reasoning includes engineering, design, fault finding, manufacturing planning, scientific analysis, medical diagnosis, financial analysis. Example of mundane tasks. Speech recognition, a process of converting a speech signal to a sequence of words. Computer speech recognition reached a user-free level for limited purposes in the 1990s. In spite of using computers for recognizing speech quite convenient, most users find the keyboard and the mouse still more convenient. The typical usages are voice dialing, call routing, data entry, speaker recognition. The spoken language interface Pegasus in the American Airlines EC Sabre reservation system allows users to obtain flight information and make reservations over the telephone. Understanding natural language. Automated generation and understanding of natural human languages are done by natural language processing (NLP), natural language generation system. It converts information from computer databases into normal sounding human language. Natural language understanding system converts samples of human language into more formal representations that are easier for computer programs to manipulate. Some major tasks in NLP. Text-to-speech (TTS) system converts normal language text into speech. Speech recognition (SR) system, process of converting a speech signal to a sequence of words. Machine translation (MT) system, translate text or speech from one natural language to another. Information retrieval system (IR) system, search for information from database such as Internet or World Wide Web or intranets. Examples for formal tasks. Game playing. Game is an emerging area. It is an interactive computer program where the goals of human-level AI are pursued. Games are made by creating human-level artificially intelligent entities. Example, partners, enemies, and support characters that act just like humans. Gameplay is a search problem defined by initial state, board, expand function, build all successor states, cost function, payoff of the state, goal test, ultimate state with maximal payoff. Game playing is characterized by unpredictable opponent, need to specify move for every possible opponent reply, time limits. Games become boring if there is no action for too long a time. Opponents are unlikely to find goal, must approximate. Computer games. Computers perform at champion level games. Example, chess, Othello, backgammon. Computers perform well games. Example, bridge. computers still do badly. Example, Go and Hex. The Deep Blue chess program won over world champion Garry Kasparov. Expert tasks. Systems in which human expertise is held in the form of rules. It enables the system to diagnose situations without the human expertise. As it is man-machine system and has specialized problem-solving expertise, the expertise consists of knowledge about a particular domain, understanding of problems within that domain, and skill at solving some of these problems. Knowledge base. A knowledge engineer interviews experts in a certain domain and tries to embody their knowledge in a computer program for carrying out some tasks. One of the first expert systems was MySyn in 1974, which diagnosed bacterial infections of the blood and suggested treatments. Expert systems rely on knowledge of human experts. Example, diagnosis and troubleshooting. Detects faults and suggests corrective actions, measurements for a malfunctioning devices or process. Planning and scheduling. Analyzing a set of goals to determine and ordering a set of actions, taking into account the constraints. Example, airline scheduling of flights. Financial decision making. It is an advisory program, assists bankers to make loans, insurance companies to assess the risk presented by the customer, etc. Process monitoring and control. Analyzes real-time data, noticing anomalies, predicting trends, controlling optimality, and do failure correction. AI techniques. Having evolved, various techniques can be applied to a variety of AI tasks. The techniques are concerned with the representation, manipulation, and reason with knowledge in order to solve problems. Example, techniques not all intelligent but used to behave as intelligent. Describe and match, goal reduction, constraint satisfaction, tree searching, general, and test rule-based systems. Biology-inspired AI techniques are currently popular. Neural networks, genetic algorithms, reinforcement learning. AI techniques that make system to behave as intelligent. Describe and match. Model is a description of system's behavior. Finite state model consists of set of states, a set of input events and the relations among them. With the help of the existing current state and an input event determination of the next current state of the model is possible. As computation model is a finite state machine, it includes a set of states, a set of start states, an input alphabet, and a transition function which maps input symbols and current states to a next state. Computational systems which are represented include start and end state descriptions and a set of possible transition rules. Transition relation is a pair of states S, S dash is such that one moves takes the system of S to S dash. Then the transition relation is represented by S implies S dash. State transition system is otherwise known as deterministic if every state has at most one successor. It is called non-deterministic if at least one state has more than one successor. Example, towers of Hanoi puzzle. Describe and match. Example, puzzle. Towers of Hanoi with only 2 disks. Moves the disks from the leftmost post to the rightmost post. Never puts a larger disk on top of a smaller one. Move one disk at a time from one peg to another. Middle post can be used for intermediate storage. Play the game in the smallest number of moves possible. Possible state transitions in the towers of Hanoi with only 2 disks. Shortest solution is the sequence of transitions from the top state downward to the lower left. Describe and match. Example, puzzle. Towers of Hanoi with only 2 disks. Moves the disks from the leftmost post to the rightmost post. Never puts a larger disk on top of a smaller one. Move one disk at a time from one peg to another. Middle post can be used for intermediate storage. Play the game in the smallest number of moves possible. Possible state transitions in the towers of Hanoi with only 2 disks. Shortest solution is the sequence of transitions from the top state downward to the lower left. Goal reduction. Goal reduction procedures are a special case of the procedural representations of knowledge in AI, an alternative to declarative, logic-based representations. It narrows down the hierarchical subdivision of goals into sub-goals until or unless the sub-goals which have an immediate solution are reached and set goals has been fulfilled. The relationship between goals and sub-goals, alternative sub-goals, and cojoint sub-goals can be represented by an AND or tree or graph structure. Goal reduction. Example: AND or tree or graph structure to represent facts such as enjoyment, earning or save money, old age. Constraint satisfaction techniques. Constraint denotes the logical relation among variables. Example: circle is inside the square. The constraints relate objects without exactly specifying their positions. The relation still remains the same, though any one of variables moves. Constraint satisfaction is a process to find out a solution for setting constraints. The constraints express allowed values for variables, and finding solution is evaluation of these variables that satisfies all constraints. Constraint satisfaction problem (CSP) and its solution consist of variables, a finite set x is equal to x1 up to xn. Domain, a definite set di of possible values which variable xi can take. Constraints, a set of values that variables can simultaneously satisfy the constraint. Example: d1 not equal to d2. CSP has application in AI, programming languages, symbolic computing, and computational logic. Example: map coloring. If a map is given, graph with number of colors, the problem is to assign colors to those areas in the map nodes, satisfying the constraint, making very sure that all adjacent nodes areas have not at all been assigned same color to them. Solution: to model this map coloring problem, label each node of the graph with a variable. Introduce the non-equality constraint between two variables, labeling adjacent nodes. A 4-color map. The 4-color theorem states that 4 colors are effectively enough sufficient to color any map. It brings out a result that regions sharing a common border receive different colors. Tree searching. Tree searching can be a mode of describing many problems. A solution is to find a path through this tree. A complete search through the entire tree till a satisfactory path is found is called exhaustive search. Tree search strategies: hill climbing, breadth first search, beam search, best first search. Rule-based systems (RBS). Rules are of the form if, condition, then action. Rules are often arranged in hierarchies and or trees. If all conditions of a rule are satisfied, the rules can be triggered. RBS components: working memory, rule base, interpreter. RBS components: working memory, rule base, interpreter. Working memory incubates facts that the rule derivation and its observation, stored as a triplet: object, attribute, values. Example: car, color, red. The color of my car is red. Contains temporary knowledge about problem-solving session. Can be modified by the rules. Rule base. It contains rules. Each rule is a step forward in problem solving. Rules are based on domain knowledge and modified only from outside. Rule syntax is if condition, then action. Example: if temperature over 20, then add ocean swimmable, yes. If the conditions are matched to the working memory and fulfilled, rule may be fired. Add facts to WM, remove facts from WM, modify facts in WM. Interpreter. It is the domain-independent reasoning mechanism for RBs. It selects rule from rule base and applies by performing action. It operates on a cycle. Retrieval. Finds the rules that matches the current WM. Refinement. Prunes, reorders, and resolves conflicts. Execution. Executes the action of the rules in the conflict set and applies the rule by performing action. Biology-inspired AI techniques. Neural network (NN). Neural networks model brain learning by example. Neural networks are structures which are trained to recognize input patterns. Neural networks typically take not only a vector of input values but also produce a vector of output values. They train weights of neurons inside of it. Example: a perceptron is a model of a single trainable neuron. X1, X2 up to Xn are inputs as real numbers or Boolean values depends on problem. W1, W2 up to Wn are weights of the edges and are real valued. T is the threshold and is real valued. Y is the output and is Boolean. If the net input, which is W1 X1 plus W2 X2 plus up to Wn Xn is greater than the threshold T, then output Y is 1 else 0. Neural networks use supervised learning. Inputs and outputs are known in supervised learning. The goal is to build a representation of a function that will approximate the input to output mapping. Genetic algorithms (GA). Besides being a part of evolutionary computing, genetic algorithms are rapidly growing areas of AI. Genetic algorithms are implemented as computer stimulation, where techniques are inspired by evolutionary biology. Mechanics of biological evolution. Every organism has a set of rules describing how that organism is built and encoded in the genes of an organism. Chromosomes are a collection of genes together into long strings. Each gene represents a specific trait of the organism and has several different settings. The genes and their settings are referred as an organism's genotype. When two organisms blend with each other, they share their genes. The resultant offspring may end up having half the genes from one parent and half from the other. This process is known as crossover. A gene may be mutated and expressed in the organism as a completely new trait. Genetic algorithms steps. Start. Generate random population of n chromosomes. Fitness. Evaluate the fitness f of x of each chromosome x in the population. New population. Create a new population by repeating following steps until the new population is complete. Selection. Select two parent chromosomes from a population according to their fitness. Crossover. With the crossover portability, cross over the parents to new offspring child. If no crossover takes place, offspring is the exact copy of the parents. Mutation. With the mutation probability, mutate new offspring at each locus, position in chromosome. Accepting. Place new offspring in the new population. Replace. Use new generated population for a further run of the algorithm. Test. If the end condition is satisfied, stop and return the best solution in current population. Loop. Go to step 2. Reinforcement learning (RL). RL is a learning of interaction with an environment. Internal mathematical framework of Markov decision process (MDPs) conducts RL. The basic RL model consists of a set of environment states S, a set of actions A. A set of scalar rewards R. The received cumulative can be maximized by the decision-making agent's interaction with its environment. The steps are: at each time t, the agent perceives its environment state as t, and the set of the possible actions A of s to the base t. It chooses an action A belongs to A of s to the base t and receives from the environment to the new state s to the base t plus 1 and a reward r to the base t plus 1. Based on these interactions, the agent develops a policy pi colon s implies A, which maximizes the quantity r is equal to r0 plus r1 plus up to rn for MDPs. Data pyramid. For representing purported structural are used, which are indicated by data pyramid, and or functional relationships between data, information, knowledge, and wisdom. Typically, information is defined in terms of data, knowledge in terms of information, and wisdom in terms of knowledge, respectively. The animation shows the relationship existing among data, information, knowledge, and intelligence. The data is converged into knowledge by applying activities like researching, absorbing, acting, interacting, and reflecting. These activities are shown on x-axis. A human normally gains understanding and experience and may come up with innovative ideas. The y-axis represents convergence, which are namely raw observation, concepts, rules, models, and heuristics. Computer-based information systems, CBIS. A computer-based information system is essentially an information system using computer technology to execute a few or all planned tasks. The basic components of computer-based information system are hardware. These are the devices like the monitor, processor, printer, and keyboard work together to accept, process, show data and information. Software. It is the program that allows the hardware to process the data. Databases. Databases are the gathering of associated files or tables containing related data. Networks. Networks are connecting system that allows a diverse computers to distribute resources. Procedures. Procedures are the commands for combining the components above to process information and produce the preferred output. What is artificial intelligence? The term artificial intelligence was coined by John McCarthy in 1956. It defines as it is the science and engineering of making intelligent machines, especially intelligent computer programs. Artificial intelligence is not only the intelligence of machines, but also the branch of computer science which aims to create intelligence. Intelligence is a part of computation ability to achieve goals in the world. Varying kinds and degrees of intelligence occur in people, many animals, and some machines. AI is the study and design of intelligent agents, where an intelligent agent is a system that receives its environment and takes action that maximizes its chance of success. AI is the study of the mental faculties through the use of computational models. Intelligence. Intelligence is related to tasks involving higher mental processes. Examples: creativity, learning, pattern recognition, classification, induction, optimization, solving problems, and language processing, etc. The computational part of the ability to achieve goals is termed as intelligence. Intelligent behavior. Perceiving one's environment, acting in complex environments, learning and understanding from experience, reasoning to solve problems and discover hidden knowledge, applying knowledge successfully in new situations, thinking abstractly, using analogies, computing with others, creativity, ingenuity, expressiveness, and curiosity. Understanding AI. How knowledge is acquired, represented, and stored. How intelligent behavior is generated and learned. How motives, emotions, and priorities are developed and used. How sensory signals are transformed into symbols. How mechanisms of intelligence produce the phenomena of illusion, belief, hope, fear, dreams, and kindness. Hard or strong AI. Artificial intelligence research aims at creating AI that can replicate human intelligence completely. Strong AI refers to a machine that approaches or supersedes human intelligence like the following. If it can do typically human tasks, if it can apply a wide range of background knowledge, and if it has some degree of self-consciousness. Strong AI aims to build machines whose overall intellectual ability is unquestionably equal to that of a human being. Weak AI. The use of software is indicated as weak AI. It is meant to study or accomplish specific problem-solving or reasoning tasks, which do not encompass the full range of human cognitive abilities. Example, a chess program such as Deep Blue. Self-awareness is not being attained by weak AI. It demonstrates wide range of human-level cognitive abilities. It is merely an intelligent, a specific problem solver. Cognitive science aims to develop, explore, and evaluate theories of how the mind works through the use of computational models. The end doesn't matter, but the means matters a lot. It means that intelligent behavior is not enough, but the program ought to operate in an intelligent manner. Example, the chess programs are successful, but they say little about the ways humans play chess. Goals of AI. The definitions of AI insist the following goals. Systems that think like humans, systems that think rationally, systems that act like humans, systems that act rationally. Traditionally, all four goals have been followed. They are shown here. And the approaches were human-like think, cognitive science approach, act, Turing test approach. Rationally think, laws of thought approach, act, rational agent approach. General AI goals. Replicate human intelligence. Still a distant goal. Solve knowledge-intensive tasks. Make an intelligent connection between perception and action. Enhance human-to-human, human-to-computer, and computer-to-computer interaction or communication. Engineering-based AI goal. Develop concepts, theory, and practice of building intelligent machines. Emphasize falls on system building. Science-based AI goal. Develop concepts, mechanisms, and vocabulary to understand biological intelligent behavior. Emphasis on understanding intelligent behavior. What is the nature of AI solution? Acceptable solution in acceptable time. Extreme solution, either best or worst, taking infinite time. What is testing intelligence? Various experiments have been introduced to measure the degree of intelligence and level of machine understanding achieved. The Turing test by Alan Turing, 1950, and the Chinese room experiment by John Searle, 1980, are two important measures. Turing test. The art of creating machines perform functions. To perform, it requires intelligence when performed by people. That it is the study of how to make computers capable of doing better than human being. Focus lies on action and not intelligent behavior centered on representation of the world. A behaviorist approach is not concerned with the how to get results, but to the similarity to what human results are. Example, 3 rooms contain a person, a computer, and an interrogator. The interrogator can communicate with the other 2 by teletype. The interrogator tries to determinate between person and the machine. The machine tries to fool the interrogator to believe that it is the human, and the person also tries to convince the interrogator that he is the human. If the interrogator is made to be a fool, sum up that the machine is intelligent. Goal is to develop systems that are human-like. A human judge engages in natural language conversation with two other parties, namely a human and a machine. If the judge cannot reliably judge which is which, who is which, or which is who, the machine is said to pass the test. It is assumed that both the human and the machine try to appear human. The boss could not judge who was replying. Thus, the machine is as intelligent as the secretary. Objections. Though a machine passing the test could simulate human behavior, this might be considered much weaker than intelligence. The machine might just follow a set of cleverly designed rules. Turing rebutted this by saying that maybe the human mind is just following a set of cleverly designed rules as well. A machine could be intelligent without being capable of conducting conversations with humans. Many humans might fall as a prey to this test if they are illiterate or inexperienced. Example, children. Chinese room experiment. A man who doesn't speak Chinese sits in a room and is handed sheets of paper with Chinese symbols, logographic writing, through a slit. He has access to a manual with a comprehensive set of rules on how to respond to this input. Searle argues that even though he can answer correctly, he doesn't understand Chinese. He is just following syntactical rules and doesn't have access to the meaning of them. Searle believes that mind emerges from brain functions, but it is more than a computer program. It requires intentionality, consciousness, subjectivity, and mental causation. Conclusion. In this chapter, we have covered the following in detail. Natural and artificial intelligence. Definitions of AI. Nature of AI solutions. AI techniques. Testing intelligence. 1. Turing test. 2. Chinese room test. Data pyramid. Computer-based information systems in the pyramid. AI applications areas. Mundane tasks, formal tasks, and expert tasks.